You're standing at the edge of a cliff on a clear night, gazing up at thousands of stars scattered across the darkened canvas of space. Each pinpoint of light, a sun potentially orbited by planets not unlike our own. As you stare into the abyss, a thought creeps into your mind that philosophers and scientists have pondered for centuries. Are we alone? But what if we've been asking the wrong question all along? What if the real mystery isn't whether alien civilizations exist, but rather why we haven't found them yet? Tonight, we're going to venture beyond the boundaries of what we know, past the limits of what we can see, to explore a possibility both terrifying and awe-inspiring. The idea that the observable universe, our cosmic horizon, may be hiding the greatest secret of all. Imagine for a moment that you could travel faster than light, breaking the cosmic speed limit that constrains everything in our reality. You push outward, beyond our solar system, beyond our galaxy, beyond the billions of galaxies we can see with our most powerful telescopes. You travel for billions of light years until you reach what astronomers call the cosmic horizon, the edge of our observable universe. But here's where things get interesting. You don't encounter a wall or a boundary. Instead, as you cross this invisible threshold, you find more universe, more galaxies, more stars, more possibilities. And perhaps, just perhaps, you would find something else, evidence of intelligence. Civilizations that have flourished for billions of years, building cosmic megastructures and harnessing energies we can barely comprehend. Civilizations that might have solved the problems that threaten our existence today. Civilizations that may have wondered, just as we do, if they are alone in the cosmos. But there's a problem of physics, of light, and of time itself. These civilizations, if they exist, lie beyond a boundary that no signal can cross. No light, no radio waves, no evidence of their existence can ever reach us. And likewise, they will never know that we exist. This is not science fiction. This is the reality suggested by our current understanding of cosmology, of inflation theory, and of the accelerating expansion of our universe. It raises profound questions about our place in the cosmos. If we're forever cut off from civilizations, beyond our cosmic horizon, does it even matter if they exist? What does it mean for humanity's future if we are effectively alone in our observable bubble of space-time? And most intriguingly, what if there are regions of space where the laws of physics themselves are different, allowing for forms of life and intelligence we cannot even imagine? Today, we're going to embark on a journey to the edge of knowledge itself. We'll explore the latest theories in cosmology and physics. We'll examine the search for extraterrestrial intelligence and why it has so far come up empty. And we'll confront the mind-bending implications of what lies beyond what we can see. The answers might shake the very foundations of how you see reality and our place within it. Because the truth may be more extraordinary than we've ever dared to imagine. We may be just one among countless civilizations, separated not by the vastness of space, but by the fundamental boundaries of the observable universe itself. This is Beyond the Horizon, the search for civilizations we can never know. The search for other intelligent life in the cosmos is woven deeply into humanity's cultural fabric, stretching back to our earliest civilizations. Ancient stargazers in Mesopotamia, Egypt, China, and Greece didn't merely chart the heavens. They imagined them populated with gods, spirits, and perhaps even beings like themselves. The Greek philosopher Epicurus wrote in 300 BCE, "There are infinite worlds both like and unlike this world of ours. We must believe that in all worlds there are living creatures and plants, and other things we see in this world. Even then, the concept of plurality, that Earth couldn't possibly be the only home to conscious life, seemed intuitive to many deep thinkers. Yet for much of human history, our cosmic perspective remained severely limited. The Earth was seen as the center of all creation, a unique stage upon which the drama of life unfolded. This Ptolemaic model persisted for over a millennium until a quiet, unassuming Polish canon named Nicolaus Copernicus began to question everything. Working mostly in isolation in the early 16th century, Copernicus meticulously observed the movements of planets and stars, filling notebook after notebook with calculations that didn't align with the accepted view. The story goes that Copernicus was so fearful of persecution for his radical ideas that he waited until he was on his deathbed in 1543 to publish On the Revolutions of the Celestial Spheres. Legend has it that the first printed copy was placed in his hands just hours before he died. With this publication, Earth was suddenly demoted, no longer the center of everything, but merely one planet orbiting an ordinary star. This Copernican revolution represented the first great humbling of humanity's cosmic ego, though certainly not the last. Imagine being Giordano Bruno, an Italian friar in the late 16th century, who dared to take Copernicus's ideas even further. On a cool evening in 1584, while walking through the narrow streets of London, Bruno was overwhelmed with a vision that would ultimately cost him his life. He saw not just a sun-centered solar system, but an infinite universe filled with countless stars, each potentially hosting inhabited worlds. There are innumerable suns and innumerable Earths orbiting these suns, he proclaimed. Living beings inhabit these worlds. For such heretical thoughts, Bruno was burned at the stake in 1600, his ashes scattered along the Tiber River, a grim warning to others who might challenge orthodoxy. The telescope's invention in 1608 transformed these philosophical musings into scientific inquiry. When Galileo Galilei first pointed his crude instrument toward Jupiter in 1610, he discovered 4 moons orbiting the giant planet, proof that not all celestial bodies revolved around Earth. With each new discovery, our cosmic significance seemed to diminish, while paradoxically, the possibility of other inhabited worlds grew. By the 18th century, the pendulum had swung dramatically. Many leading intellectuals not only accepted the possibility of extraterrestrial life, but considered it a certainty. The great mathematician Christian Huygens wrote Cosmotheoros in 1698, a detailed speculation on what life might be like on other planets. Emanuel Swedenborg, the Swedish scientist and mystic, claimed to have visited other planets through spiritual journeys, describing their inhabitants in elaborate detail. Even Immanuel Kant, the towering figure of Enlightenment philosophy, wrote that it would be absurd to think that other planets would be uninhabited while Earth teemed with life. The 19th century brought both progress and peculiar sidesteps in our understanding. Percival Lowell, a wealthy Boston aristocrat turned astronomer, became obsessed with the apparent canals on Mars reported by Italian astronomer Giovanni Schiaparelli in 1877. Lowell established an observatory in Flagstaff, Arizona, specifically to study these features, producing detailed maps of what he believed were massive engineering works constructed by a desperate Martian civilization trying to survive on a dying planet. That Mars is inhabited by beings of some sort or other, we may consider as certain, Lowell wrote confidently in 1895. Lowell's ideas captured the public imagination, inspiring H.G. Wells' War of the Worlds and a generation of science fiction about Martian civilizations. Though we now know the canals were optical illusions, Lowell's passionate advocacy for extraterrestrial life brought the question into mainstream scientific discourse. While astronomers debated the possibility of Martians, physicists were making discoveries that would fundamentally reshape our understanding of the cosmos. In a small patent office in Bern, Switzerland, a young clerk named Albert Einstein spent his lunch breaks and evenings developing ideas that would overturn Newton's view of the universe. In 1905, his Annus Mirabilis, Einstein published papers that established the constancy of light's speed and the equivalence of mass and energy, concepts that would later become crucial to understanding the observable universe's limits. But even Einstein initially struggled with the implications of his own theories. When he applied his equations to the universe as a whole in his general theory of relativity in 1915, he found something troubling, a universe that wouldn't stand still. His equations suggested the cosmos should be either expanding or contracting, not static as everyone assumed. Uncomfortable with this prediction, Einstein added a cosmological constant to his equations, essentially a fudge factor to keep the universe stationary. In a small corner of America, an unlikely figure was about to prove Einstein wrong. Milton Humason had dropped out of school at age 14 to become a mule driver, hauling supplies up the mountain to the Mount Wilson Observatory near Los Angeles. Through persistence and natural talent, he rose from janitor to become a skilled assistant to the astronomer Edwin Hubble. Together, they undertook the painstaking work of measuring the light from distant galaxies. On a cold night in 1929, analyzing their latest measurements, Hubble and Humason made a discovery that would forever change our cosmic perspective. The light from distant galaxies was universally shifted toward the red end of the spectrum, and the farther away the galaxy, the greater this redshift. The inescapable conclusion: the universe was expanding. Einstein would later call the cosmological constant his greatest blunder. This expanding universe had profound implications for the question of extraterrestrial civilizations. If the universe had a beginning, what would later be called the Big Bang, then it had a finite age. Life and intelligence would have had only so much time to evolve. But an expanding universe also meant vastness beyond comprehension. Billions of galaxies, each with billions of stars, spreading out across cosmic time. The mid-20th century brought the first serious attempts to detect signals from extraterrestrial intelligence. In 1960, a young astronomer named Frank Drake pointed the 85-foot telescope at Green Bank, West Virginia, toward two nearby sun-like stars, Tau Ceti and Epsilon Eridani. For 6 hours a day, over 4 months, Drake searched for artificial radio, signals in what he called Project Ozma, named after the queen of L. Frank Baum's fictional Land of Oz. Though he detected nothing unusual, the project marked the birth of SETI, the search for extraterrestrial intelligence. A year later, at a small conference at Green Bank, Drake presented what would become known as the Drake equation, a formula for estimating the number of detectable civilizations in our galaxy. The equation multiplied 7 factors, from the rate of star formation to the fraction of civilizations that develop detectable technology. Depending on the values assigned to these variables, the equation could predict anywhere from thousands of advanced civilizations in our galaxy to less than one, essentially just us. This wide range of possibilities led the physicist Enrico Fermi to pose his famous paradox over lunch with colleagues at Los Alamos National Laboratory. "Where is everybody?" he asked. "If the universe is ancient and vast, with billions of potential life-bearing planets, then technological civilizations should have arisen multiple times. Some should have developed interstellar travel and colonized large portions of the galaxy. Yet we see no evidence of such civilizations, no signals, no artifacts, no visitors. This great silence, as it came to be known, remains one of science's most perplexing puzzles." As radio astronomers scanned the skies for artificial signals, cosmologists were developing theories that would dramatically expand our conception of the universe itself. In 1980, the American physicist Alan Guth was struggling with several problems in the Big Bang theory, including the remarkable uniformity of the cosmos. One sleepless night, he developed the concept of cosmic inflation, or period of exponential expansion in the universe's first fraction of a second. Inflation explained the universe's uniformity, but it came with a staggering implication. Our observable universe might be just one bubble in a vastly larger multiverse. The theory gained further support through the work of Soviet physicist Andrei Linde, who proposed eternal inflation in 1986. According to Linde's theory, the process that created our universe continues endlessly, spawning innumerable other universes, each with potentially different physical constants and laws. While working at CERN in Switzerland, Linde received a phone call at 1 a.m. from the BICEP 2 team, who believed they had found evidence supporting inflation theory. Though their results were later found to be contaminated by cosmic dust, the search continues. Meanwhile, the notion of a cosmic horizon, a fundamental limit to what we can observe, emerged from our understanding of the universe's expansion. Light from beyond this horizon cannot reach us because the expansion of space itself exceeds the speed of light. In 1998, this concept gained new significance when two independent teams of astronomers discovered that the universe's expansion is not slowing down as expected, but accelerating. Suddenly, the cosmic horizon became not just a temporary limitation, but a permanent boundary. Regions of space that we will never be able to observe, no matter how long we wait. This accelerating expansion, attributed to a mysterious dark energy that permeates space, suggested something profound. If civilizations exist beyond our cosmic horizon, we will never detect them, nor they us. It's not merely a practical limitation, but a fundamental one woven into the fabric of our reality. The physicist Sean Carroll described it poignantly. We live in a universe where some of the most basic questions may be permanently beyond our reach. By the dawn of the 21st century, our understanding of the cosmos had undergone multiple revolutions, from an Earth-centered universe to an infinite multiverse, from a unique abode of life to one of countless potential habitats, from a static cosmos to an accelerating expansion, driving galaxies permanently beyond our view. Each step revealed both our cosmic insignificance and the extraordinary fortune of our existence. The quest to find other minds in this vast expanse continues, now informed by the humbling possibility that the most profound answer may lie just beyond what we can ever know, the civilizations forever hidden beyond our cosmic horizon. To understand why civilizations might exist beyond our observable universe and why we can never contact them, we need to unravel some of the most fascinating concepts in modern cosmology. Let's start with something seemingly simple. What exactly is the observable universe? Imagine you're standing in the middle of a dark forest at night with a flashlight. The beam only reaches so far, perhaps 100 feet in any direction. Beyond that boundary lies more forest, but it remains invisible to you. The observable universe works similarly, except instead of a flashlight, we're limited by the fundamental speed of light and the age of the universe itself. When you look up at the night sky, you're not seeing stars and galaxies as they are now, but as they were when their light began its journey toward Earth. The light from our sun takes about 8 minutes to reach us, so we see the sun as it was 8 minutes ago. The light from the nearest star system, Alpha Centauri, takes over 4 years to arrive. And the most distant galaxies we can observe, their light has been traveling for nearly 13.8 billion years, almost the entire age of the universe. This creates a natural boundary around us, a cosmic horizon beyond which we simply cannot see. Think of it like this. Imagine you're standing on the shore of a vast ocean. You can see several miles out to the horizon, but you can't see what lies beyond that curve. You know the ocean continues, but your line of sight is limited by Earth's curvature. Our cosmic horizon works similarly, but it's created by the finite age of the universe and the finite speed of light. We cannot see beyond roughly 46.5 billion light-years in any direction, the current radius of the observable universe, because light from those regions hasn't had enough time to reach us yet. But here's where things get truly mind-bending. The universe is almost certainly much larger than what we can observe. In fact, it may be infinite. Cosmologists arrived at this conclusion through several independent lines of evidence. But one of the most compelling comes from studying something called the cosmic microwave background radiation, the afterglow of the Big Bang itself. Picture yourself in a hot air balloon, floating above a vast landscape. You can see a certain distance in all directions, perhaps 30 miles to the horizon. But you know the Earth is much larger than your visible circle. How could you determine the overall shape of the Earth from your limited vantage point? One way would be to carefully map the features you can see and look for patterns that might reveal the larger structure. This is essentially what cosmologists did with the cosmic microwave background. When scientists first mapped this ancient light in detail using satellites like WMAP and Planck, they measured tiny temperature fluctuations, just a few millionths of a degree, across the sky. These fluctuations form patterns that tell us about the universe's overall geometry. To their surprise, the data indicated that the universe is flat, not in the sense of being two-dimensional, but in the geometric sense that parallel lines remain parallel forever. This flatness suggests that the universe is either infinite, or at least vastly larger than what we can observe. Now let's introduce another crucial concept: cosmic inflation. In the 1980s, physicists realized that the early universe must have undergone a period of incredibly rapid expansion, doubling in size every tiny fraction of a second, to explain certain features we observe today. This inflationary period would have stretched the fabric of space-time like a balloon being inflated at an exponential rate, smoothing out irregularities and establishing the large-scale structure of our cosmos. Imagine a single dot on a balloon's surface. As you blow up the balloon, that dot doesn't just move away from you, it also expands. Similarly, space itself expanded during inflation, stretching quantum fluctuations into the seeds of today's galaxies and cosmic structures. But inflation doesn't just explain our observable universe. It suggests something far more profound. According to the theory of eternal inflation, developed by physicists like André Linde and Alan Guth, this inflationary process doesn't happen uniformly everywhere. Instead, different regions of space stop inflating at different times, creating bubble universes with potentially different physical properties. Our observable universe would be just one such bubble in a vast multiverse, a cosmic ocean filled with countless other universes, each with its own laws of physics, constants, and possibilities. To visualize this, think of a pot of boiling water. As the water boils, bubbles form, expand, and rise to the surface. Each bubble is separate from the others, with its own boundary. Similarly, bubble universes would be separated from each other, with no possibility of communication between them. This is one way we might be cut off from other civilizations. They could exist in entirely different bubble universes with no causal connection to our own. But even within our own bubble universe, there's another barrier that might forever separate us from distant civilizations: the accelerating expansion of space itself. In 1998, Two independent teams of astronomers made a shocking discovery while studying distant supernovae. The universe's expansion isn't slowing down due to gravity, as everyone expected. Instead, it's speeding up. To understand this counterintuitive finding, imagine a loaf of raisin bread rising in the oven. As the dough expands, each raisin moves away from every other raisin. Raisins that are farther apart move away from each other faster, simply because there's more expanding dough between them. Galaxies work the same way. They're like raisins embedded in the expanding dough of space-time. But with the universe's accelerating expansion, it's as if someone is continuously turning up the oven temperature, making the dough expand faster and faster over time. This acceleration has profound implications for our cosmic future. Galaxies that are sufficiently far away from us are receding faster than the speed of light. Not because they're breaking any cosmic speed limits, but because the space between us is stretching so rapidly that light from those galaxies will never reach us, no matter how long we wait. And this boundary, the cosmic event horizon, is shrinking over time. Eventually, in the distant future, all galaxies outside our local group will fade from view as they're carried beyond our cosmic horizon by the relentless expansion of space. But what does all this have to do with alien civilizations? Everything, as it turns out. If intelligent life evolves in galaxies beyond our cosmic event horizon, we will never be able to contact them or even detect their existence. The light from their stars, the radio signals from their civilizations, will never reach us because the space between us is expanding too rapidly. It's as if we're on one ice floe and they're on another, with the ocean between us widening faster than we could ever swim. This brings us to one of the most profound and unsettling solutions to Fermi's paradox: the apparent contradiction between the high probability of extraterrestrial civilizations and our lack of contact with them. Maybe the universe is teeming with intelligent life, but the vast majority exists beyond our cosmic horizon, forever invisible to us. We're like islanders on a remote archipelago in the Pacific, unaware of the bustling civilizations on distant continents because the ocean between us is too vast to cross. But there's yet another layer to this cosmic mystery, one that touches on the nature of reality itself. According to quantum mechanics, our best theory of the subatomic world, the universe is probabilistic rather than deterministic. Multiple outcomes can exist in superposition until an observation causes this quantum wave function to collapse into a definite state. This strange behavior has led some physicists to propose the many worlds interpretation, which suggests that every possible outcome of every quantum event actually occurs, just in different, parallel universes that can never interact with each other. Imagine flipping a coin. According to the many worlds interpretation, the universe splits into two branches, one where the coin lands heads, and another where it lands tails. Both outcomes are equally real, but they exist in separate, non-communicating realities. Now, extend this to every quantum event that has ever occurred in the universe's history, and you end up with an unfathomable number of parallel universes, each slightly different from the others. In some of these parallel universes, intelligent life might have evolved differently or not at all. There could be versions of Earth where dinosaurs never went extinct, where humans never evolved, or where civilization took a radically different path. And in countless others, advanced civilizations might have developed technologies we can barely imagine, solved problems we still struggle with, and expanded throughout their galaxies. But here's the crucial point. According to the many worlds interpretation, all these parallel universes exist alongside ours in a higher dimensional space, but they can never interact with each other. Information cannot pass between these branches of reality. So even if an incredibly advanced civilization exists in a parallel universe that's otherwise identical to ours, occupying the same physical location but in a different quantum branch, we would have no way of detecting them or communicating with them. This brings us to a startling possibility. The universe might be saturated with intelligent life, existing in three distinct realms that can never interact with each other. First, there might be civilizations in distant parts of our own observable universe, potentially detectable through astronomy and SETI efforts. Second, there could be civilizations beyond our cosmic horizon, forever invisible to us due to the universe's accelerating expansion. And third, there might be countless civilizations in parallel quantum branches of reality, existing in the same physical location as us, but in different versions of the universe. The implications are both humbling and awe-inspiring. We might be surrounded by a cosmic internet of intelligent civilizations, all sending signals into the void. Yet most are forever beyond our reach due to the fundamental structure of reality itself. It's as if we're all broadcasting on different frequencies that can't be tuned into, or speaking languages that can never be translated. But what if, and this is a big what if, some hypothetical advanced civilization found a way to circumvent these cosmic barriers? What if they discovered how to send signals between bubble universes, or how to communicate across the expanding cosmic horizon, or even how to bridge the gaps between quantum branches of reality? The laws of physics as we currently understand them say this is impossible, but the history of science is full of impossibilities that were later overcome through deeper understanding. For most of human history, it was impossible to fly, to see atoms, to visit the moon, or to instantly communicate with someone on the other side of the planet. Maybe the cosmic barriers that separate us from other civilizations are not absolute, but simply reflect the limits of our current understanding. Some speculative ideas have already been proposed. Theoretical physicist Juan Maldacena has explored how certain quantum-entangled particles might encode information about distant regions of space-time through what's called the holographic principle. Others have suggested that microscopic wormholes might create subtle connections between otherwise separate regions of the multiverse. Still others have investigated whether the cosmic microwave background might contain encoded messages from pre-Big Bang civilizations passed through to our universe like a cosmic time capsule. While these ideas remain highly speculative and well beyond our current technological capabilities, they remind us that the boundaries of knowledge are constantly expanding. What seems impossible today might become tomorrow's textbook science. The history of physics is one of successive revolutions, each revealing a deeper understanding of reality and overturning previously unquestionable assumptions. As we gaze into the night sky, contemplating the possibility of other minds in the I2T2 cosmos, we're confronted with a profound paradox. The same scientific theories that suggest the universe should be teeming with intelligent life also explain why we might never contact most of them. The cosmic horizon, the accelerating expansion of space, the bubble multiverse, quantum branching, all these concepts point to a universe, or universes, where civilizations might be common, but communication between them rare or impossible. Yet this very limitation creates a kind of cosmic urgency. If we are indeed isolated within our observable pocket of the universe, then the responsibility for preserving and spreading intelligence in our cosmic neighborhood falls entirely to us. We might be the only technological civilization capable of exploring our local group of galaxies, the only minds able to appreciate the beauty and complexity of this particular observable slice of the cosmos. And perhaps most tantalizingly, we might not be completely alone after all. While many civilizations might exist beyond these various cosmic horizons, others might exist within our observable universe, waiting to be discovered. The fact that we haven't detected them yet, the so-called Great Silence, might reflect not their absence, but the immense challenges of interstellar communication, the vast timescales of cosmic evolution, or the possibility that technological civilizations typically exist for only brief periods before transcending into forms we can't currently recognize. The search for these potentially detectable civilizations continues through projects like Breakthrough Listen, which uses powerful radio telescopes to scan nearby stars for artificial signals. Astronomers also search for technosignatures, evidence of large-scale engineering projects, unusual atmospheric compositions that might indicate industrial activity, or other signs of advanced technology. So far, these searches have come up empty, but we've barely begun to explore. We've carefully examined only a tiny fraction of the stars in our galaxy, and our detection methods remain limited. It's like trying to find a specific fish in the ocean after dipping a single cup into the water. The absence of evidence is not evidence of absence, especially when we've searched so little of the cosmic ocean. As our technology improves and our search expands, we may yet detect signs of other civilizations within our cosmic horizon. But even if we never find them, even if we ultimately conclude that we are indeed alone in our observable universe, the possibility of countless civilizations beyond that horizon, forever invisible to us, remains a profound and humbling idea. We might be separated from most of the universe's intelligence, not by distance alone, but by the fundamental structure of reality itself. In this cosmic perspective, our existence becomes both more precious and more puzzling. We find ourselves on a small planet, orbiting an average star in one galaxy among billions, potentially cut off from most of the universe's intelligence by barriers we cannot cross. Yet here we are, conscious beings capable of understanding these very barriers, of peering into the abyss and contemplating our place within it. Even if we can never communicate with civilizations beyond our cosmic horizon, the simple act of recognizing their possible existence changes how we see ourselves and our future in this vast, mysterious universe. Despite our growing understanding of the cosmos, the question of extraterrestrial civilizations beyond our cosmic horizon remains shrouded in profound uncertainty. This uncertainty stems not from a lack of scientific effort, but from fundamental barriers that challenge our very ability to know. As we venture deeper into these mysteries, we encounter paradoxes and questions that continue to baffle even the most brilliant minds in cosmology, astronomy, and physics. Let's explore these challenges and see why they matter for our cosmic quest. The first, and perhaps most fundamental challenge, is what cosmologists call the cosmic variance problem. Imagine you're a marine biologist trying to understand all of Earth's oceans by studying a single drop of water. No matter how carefully you analyze that drop, you'll never get a complete picture of oceanic life. Similarly, we have access to only one observable universe, our cosmic drop, in what might be an infinite ocean. This creates a statistical nightmare. How can we determine what's typical or unusual about our cosmos when we have a sample size of exactly one? This limitation becomes particularly acute when we consider the distribution of matter and energy in the early universe. The tiny quantum fluctuations that occurred during the first fraction of a second after the Big Bang were subsequently amplified by cosmic inflation, eventually growing into the galaxies and galaxy clusters we see today. But were these fluctuations truly random? Are the structures we observe in our cosmic neighborhood representative of the universe as a whole? Without being able to observe beyond our cosmic horizon, we simply cannot know. It's the ultimate frustrating limitation in cosmology, explains theoretical physicist Max Tegmark of MIT. No matter how perfect our instruments become, no matter how many centuries we observe the sky, there will always be regions of the universe that are fundamentally unobservable to us due to the finite speed of light and the finite age of the universe. This cosmic variance problem becomes even more profound when we consider the possibility of other bubble universes within a larger multiverse. If eternal inflation theory is correct, then our universe is just one of countless bubbles, each potentially governed by different physical laws and constants. Some of these bubbles might be inhospitable to life, while others could be teeming with civilizations far more advanced than our own. Yet we have no way to observe these other bubbles directly, leaving us with theories that, while mathematically elegant, remain frustratingly untestable. This leads to a heated debate within the scientific community. What constitutes a legitimate scientific theory? The philosopher of science, Karl Popper, argued that the hallmark of science is falsifiability. A theory must make predictions that can, in principle, be proven wrong through observation or experiment. By this strict criterion, multiverse theories might be considered more metaphysics than physics, since we cannot observe other universes to test these ideas. When I was a student, I was taught that if a theory doesn't make testable predictions, it isn't science, says cosmologist Paul Steinhardt of Princeton University, a vocal critic of certain multiverse models. Now, some physicists are willing to abandon this criterion in favor of mathematical elegance or explanatory power. This is a dangerous path that risks undermining the empirical foundation of science itself. Others, like cosmologist Sean Carroll, disagree. Science isn't just about making predictions that can be tested here and now, he argues. It's about constructing the most comprehensive, coherent explanation of reality based on all available evidence. If that explanation includes entities beyond our observable universe, so be it. The multiverse isn't an idea we invented because we thought it would be cool. It's a prediction that falls naturally out of our best theories of cosmic inflation. This philosophical tension about what constitutes legitimate science becomes even more pronounced when we consider the anthropic principle, the idea that we observe the universe to have certain properties, because those properties are necessary for our existence as observers. This principle comes in weak and strong forms, with the strong anthropic principle suggesting that the universe must have the properties that allow life to develop within it at some stage. The anthropic principle has been invoked to explain the apparent fine-tuning of physical constants in our universe. For example, if the strong nuclear force were just slightly stronger or weaker, stars could not form the elements necessary for life. If the cosmological constant, which drives the accelerating expansion of the universe, were much larger, galaxies would never have formed. These and dozens of other apparent coincidences have led some physicists to argue that our universe appears fine-tuned for life. The multiverse offers one solution to this fine-tuning problem. If there are countless universes with different physical constants, then naturally we find ourselves in one of the rare universes compatible with our existence. It's a type of cosmic selection effect. We can only observe universes capable of producing observers like us. But this explanation troubles many scientists. The anthropic principle turns the scientific method on its head, argues physicist Lee Smolin. Instead of explaining our observations through fundamental principles, it explains the principles through our existence as observers. This is logically coherent, but scientifically unsatisfying. It feels like giving up on finding deeper explanations. This debate about fine-tuning and the anthropic principle has profound implications for the question of extraterrestrial civilizations. If our universe is somehow special or fine-tuned for life, then perhaps intelligent civilizations are common. But if our bubble universe just happens to have life-friendly parameters by chance, with countless others being sterile, then the rarity of life may extend beyond our cosmic horizon and throughout the multiverse. Beyond these philosophical challenges, lies an even more perplexing puzzle. Fermi's Paradox. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" During a lunch discussion about extraterrestrial life, this paradox highlights the contradiction between the high probability of extraterrestrial civilizations and our lack of evidence for their existence. Given that our galaxy contains hundreds of billions of stars, many with potentially habitable planets, and has existed for over 13 billion years, there has been ample time and opportunity for technological civilizations to arise and spread throughout the Milky Way. Even with spacecraft traveling at just a fraction of light speed, the entire galaxy could be colonized within a few tens of millions of years, a mere eye blink in cosmic terms. Yet we see no evidence of such widespread colonization, no artificial signals in our astronomical data, no visitors to our solar system. The solutions proposed to Fermi's paradox are as numerous as they are unsettling. Perhaps technological civilizations invariably destroy themselves before achieving interstellar travel. Perhaps advanced civilizations choose to remain silent due to some unknown cosmic threat. Or perhaps we're simply looking for the wrong signs. A civilization millions of years ahead of ours might be unrecognizable to us, their technology indistinguishable from natural phenomena. The silence of the universe is suspicious, says astrobiologist David Grinspoon. Either we're missing something fundamental about the frequency of life and intelligence in the cosmos, or there's some great filter that prevents civilizations from becoming detectable on a galactic scale. Both possibilities are profoundly important. The Great Filter hypothesis suggests that there's some developmental step between simple life and galaxy-spanning civilization that is extraordinarily difficult to pass. This filter could be behind us. Perhaps the emergence of complex life is incredibly rare, and we've already passed the hardest step. Or it could lie ahead. Perhaps nearly all technological civilizations destroy themselves before achieving interstellar capabilities. Recent discoveries of potentially habitable exoplanets have only deepened the mystery. NASA's Kepler mission and other surveys have revealed that planets are common in our galaxy, with perhaps 40 billion Earth-sized worlds in habitable zones around their stars in the Milky Way alone. The raw materials for life, water, carbon, and other essential elements appear abundant throughout the cosmos, yet still no signs of other technological civilizations. Some scientists have proposed that civilizations beyond our cosmic horizon might offer a partial solution to Fermi's paradox. Perhaps intelligent life is exceedingly rare, with only a few technological civilizations arising per observable universe-sized volume of space. In that case, the nearest extraterrestrial civilization could be beyond our cosmic horizon, forever undetectable to us. But this explanation feels unsatisfying to many researchers. It doesn't explain why our own galaxy, with its hundreds of billions of stars, appears to be devoid of technological activity. The accelerating expansion of the universe introduces yet another wrinkle to this cosmic mystery. As mentioned earlier, galaxies beyond a certain distance are receding from us faster than the speed of light due to the expansion of space itself. This means there's a boundary, the cosmic event horizon, beyond which we can never receive signals, no matter how long we wait. What's unsettling is that this boundary is shrinking over cosmic time. Galaxies currently visible to us will eventually disappear beyond this horizon as the universe's expansion accelerates. In the far future, observers in our galaxy will see an increasingly empty universe, with all other galaxies except those in our local group having disappeared beyond the cosmic horizon. This cosmic loneliness scenario raises troubling questions about knowledge and cosmic history. Future civilizations arising in our galaxy billions of years from now would be unable to observe distant galaxies or the cosmic microwave background. They would have no direct evidence of the Big Bang, cosmic inflation, or the universe's accelerating expansion. Their cosmology would be fundamentally incomplete, missing crucial evidence that we take for granted today. It's sobering to realize that we live in a special cosmic epoch, explains cosmologist Katie Mack. We can see the universe's history written in the sky, but future civilizations, even in our own galaxy, will be increasingly isolated, with much of the evidence for how the universe began and evolved having disappeared beyond their cosmic horizon. This realization adds urgency to our search for extraterrestrial intelligence. If there are civilizations within our cosmic horizon, we may have a limited window to detect and potentially communicate with them before the accelerating expansion isolates different regions of the universe permanently. But the challenges to detecting such civilizations are immense, even if they exist within our observable universe. The vastness of space, the limitations of our technology, and the question of how to recognize truly alien technology all present formidable obstacles. Consider the challenge of interstellar communication. Radio waves, which have been the focus of most SETI search for extraterrestrial intelligence efforts, spread out and weaken with the square of distance traveled. A signal that might be easily detectable from a neighboring star system would be extraordinarily faint if coming from thousands of light years away. And that assumes alien civilizations would use radio technology at all. They might communicate using neutrinos, gravitational waves, or methods we haven't even conceived of yet. Then there's the question of timing. Human civilization has been technologically capable of interstellar communication for less than a century. A cosmic eye blink. If alien civilizations have similar technological lifespans, the chances of two technological civilizations existing simultaneously within detectable range of each other are vanishingly small, unless such civilizations are extremely common. The SETI problem isn't just about spatial distance, explains astronomer Jill Tarter, one of the pioneers of the search for extraterrestrial intelligence. It's a four-dimensional search across space and time. We need civilizations to overlap not just in the same region of space, but in the same sliver of cosmic history. Even if we were to detect signals from an extraterrestrial civilization, there's the profound challenge of interpretation. Deciphering a message from an alien intelligence would likely be far more difficult than deciphering ancient human languages, for which we at least share biological and cultural references. An alien civilization's communication might be based on concepts or sensory experiences completely foreign to us. When we try to imagine communicating with an extraterrestrial intelligence, we often underestimate the difficulty, warns linguist Sherry Wells Jensen. It's not just a matter of different vocabularies or grammatical structures. Their entire conceptual framework, what constitutes a word or a sentence or even communication, might be utterly different from ours. This communication challenge connects to a deeper question that has troubled philosophers and scientists alike. How universal is intelligence? Would we even recognize an alien form of intelligence if we encountered it? Our concept of intelligence is inevitably shaped by our human experience, our biological needs, and our evolutionary history. An intelligence that evolved under completely different circumstances might have cognitive abilities and limitations vastly different from our own. Take consciousness itself, a phenomenon we don't fully understand even in human beings. Would an alien intelligence experience subjective awareness as we do? Would they have emotions, desires, curiosity? Or might they possess forms of awareness entirely unlike our own? These questions verge on the philosophical, but they have practical implications for how we search for and potentially communicate with extraterrestrial intelligence. When we search for intelligence beyond Earth, we're implicitly looking for minds somewhat like our own, notes philosopher Susan Schneider. But the most common form of intelligence in the universe might be so different from us that we would struggle to recognize it as intelligence at all. This possibility becomes even more intriguing when we consider non-biological intelligence. Many futurists predict that if technological civilizations survive long enough, they will likely develop artificial intelligence that surpasses biological intelligence in many respects. Such advanced AI might eventually replace its biological creators or merge with them in some post-biological form. If this pattern is common throughout the universe, then the most advanced civilizations might consist primarily of artificial intelligences, with goals, values, and communication methods radically different from those of their biological predecessors. Such entities might have little interest in communicating with biological intelligences like ourselves, viewing us as we might view single-celled organisms, scientifically interesting perhaps, but not conversational partners. The transition from biological to artificial intelligence may be a common evolutionary step for technological civilizations, suggests astronomer Martin Rees. If so, then the intelligence out there might be post-biological, with physical and cognitive architectures, optimized for deep space rather than for life on a planetary surface. Such post-biological intelligences might colonize the galaxy in ways we wouldn't immediately recognize. Rather than terraforming planets to make them Earth-like, they might prefer the vacuum of space, the low temperatures, and the abundant solar energy available without the interference of an atmosphere. Their artifacts might not resemble our technology at all, making them difficult to distinguish from natural astronomical phenomena. This brings us to a troubling thought. What if we've already detected evidence of extraterrestrial intelligence, but failed to recognize it as such? Astronomers occasionally observe objects or phenomena that temporarily defy explanation. Unusual light curves from distant stars, fast radio bursts with no obvious source, or unexpected chemical signatures in exoplanet atmospheres. While most of these mysteries eventually find natural explanations, some researchers wonder if we might be overlooking potential technosignatures due to our preconceived notions of what alien technology should look like. We tend to search for technologies similar to our own, explains astronomer Jason Wright, who specializes in the search for technosignatures. But a civilization thousands or millions of years more advanced than ours would likely use technologies based on physics we haven't fully mastered yet. We might be looking right at their artifacts and missing them entirely. The challenge extends beyond our conceptual limitations to practical ones as well. Our most powerful telescopes can only resolve large-scale features of nearby star systems. We currently lack the technology to directly image Earth-sized exoplanets in detail or to detect small artificial structures around distant stars. The James Webb Space Telescope and other next-generation observatories will improve our capabilities, but even they will provide only limited information about potentially habitable worlds beyond our solar system. Perhaps the greatest challenge of all is one of patience and perspective. The cosmos operates on timescales vastly longer than human lifetimes or even human civilization. Stars live for billions of years, galaxies for trillions. The universe itself has existed for nearly 14 billion years and may continue to exist for trillions more. Against this backdrop, our few decades of searching for extraterrestrial intelligence represent the merest moment, like dipping a cup into the ocean for a second and concluding that fish don't exist because we caught none. The search for extraterrestrial intelligence is an unprecedented, multi-generational scientific project, emphasizes astronomer Seth Shostak. We may need to monitor millions of star systems across multiple electromagnetic frequencies for decades, or centuries before we have a reasonable chance of success. The question is whether humanity has the patience and commitment for such a long-term endeavor. This tension between human timescales and cosmic timescales points to a deeper philosophical challenge. Can we truly comprehend the cosmic perspective? Our brains evolved to deal with threats and opportunities that operated on the scale of seconds to years, in environments spanning meters to kilometers. Yet cosmology asks us to contemplate processes unfolding over billions of years across billions of light years. Our intuitions break down at these scales, making it difficult to truly grasp the implications of concepts like the cosmic horizon or the multiverse. When we think about the universe on its largest scales, we're pushing human cognition to its limits, observes astrophysicist and science communicator Neil deGrasse Tyson. We can manipulate the math, we can run the computer simulations, but truly internalizing what it means to have regions of space-time permanently beyond our reach. That's a challenge for even the most disciplined scientific mind. This cognitive limitation becomes particularly apparent when we consider the possibility of higher dimensions. String theory, one of the leading candidates for a unified theory of physics, suggests that our universe might have additional spatial dimensions beyond the three we experience, tightly curled up at the quantum scale. Some versions of the multiverse theory propose that other bubble universes might exist in a higher dimensional bulk space. Visualizing or truly understanding these extra dimensions is nearly impossible for humans. We can describe them mathematically, but we cannot directly experience or intuitively grasp what they would be like. This raises a troubling possibility. Perhaps some of the most fundamental aspects of reality are simply beyond human comprehension, not just due to practical limitations, but due to the inherent constraints of our cognitive architecture. It's humbling to recognize that there may be aspects of the universe that human minds are fundamentally incapable of fully understanding, reflects physicist Brian Greene. Just as a dog cannot grasp calculus, no matter how carefully you explain it, there may be aspects of quantum gravity or the multiverse that exceed the limits of the human cognitive apparatus. This possibility of cognitive limits connects to another profound question. How do we know that our scientific theories accurately describe reality rather than simply providing useful models for prediction? The scientific method has proven remarkably successful at helping us navigate and manipulate the physical world. But philosophy of science reminds us that there's always a gap between our models and reality itself. This gap becomes particularly concerning when we deal with regions of reality that we cannot directly observe, such as the interior of black holes, the earliest moments of the Big Bang, or regions beyond our cosmic horizon. In these cases, we're extrapolating our theories beyond their empirically verified domains, increasing the risk that they might lead us astray. Science operates most reliably when theories can be empirically tested, cautions philosopher of science Bas van Fraassen. As we push into domains that are fundamentally unobservable, we should maintain a healthy skepticism about whether our theories are revealing genuine features of reality or simply providing useful mathematical fictions. This philosophical caution has practical implications for how we think about civilizations beyond our cosmic horizon. If the very existence of such regions depends on our extrapolation of current physical theories, and if those extrapolations might be wrong or incomplete, then our entire conception of civilizations beyond the cosmic horizon might be based on a misunderstanding of the universe's true structure. Adding to this uncertainty is the ongoing tension between general relativity and quantum mechanics, our two most successful physical theories, which have yet to be fully reconciled. General relativity describes gravity and the large-scale structure of the universe, while quantum mechanics governs the behavior of matter and energy at the smallest scales. Both theories have been confirmed by countless experiments within their respective domains, yet they offer incompatible descriptions of phenomena. where both gravity and quantum effects are important, such as the interior of black holes or the earliest moments of the Big Bang. This incompatibility suggests that neither theory offers a complete description of reality. Some more fundamental theory, perhaps string theory, loop quantum gravity, or some approach not yet conceived, must underlie both. And this more fundamental theory might radically change our understanding of the universe's structure, including the nature of the cosmic horizon and what lies beyond it. The quest for a theory of everything isn't just philosophical curiosity, explains theoretical physicist Sabine Hossenfelder. It's essential for understanding the true nature of space, time, and the cosmos as a whole. And until we have such a theory, our conception of what exists beyond our observable universe remains speculative, built on theories we know to be incomplete. This incompleteness in our physical theories connects to a deeper epistemological question. What are the limits of scientific knowledge? For centuries, scientists and philosophers have debated whether science can, in principle, explain everything about the physical world, or whether there are inherent limitations to the scientific enterprise. The cosmic horizon represents one such potential limitation, a boundary beyond which empirical science, which depends on observation, cannot directly probe. Similarly, the multiverse hypothesis suggests the existence of other universes that we cannot, even in principle, directly observe. In both cases, we face the troubling possibility that some of our most profound cosmic questions might lie beyond the reach of empirical science as traditionally conceived. Science has been remarkably successful by focusing on observable, testable phenomena, notes philosopher of science Thomas Kuhn. When we extend our theories to domains that are fundamentally unobservable, we're pushing beyond the boundaries that have historically given science its reliability and precision. We should be honest about the speculative nature of such extensions, yet many physicists and cosmologists argue that we can still make meaningful progress on understanding these unobservable domains through indirect evidence, mathematical consistency, and explanatory power. Just as geologists infer the structure of Earth's core without directly observing it, or paleontologists reconstruct extinct ecosystems from fragmentary fossil evidence, cosmologists might infer the properties of regions beyond our cosmic horizon from the patterns and structures we can observe within it. Science has always involved inference to unobservable entities, argues cosmologist Max Tegmark. No one has directly observed an electron or a black hole, yet we're confident they exist because of their explanatory role in our best scientific theories. The multiverse and regions beyond our cosmic horizon deserve the same consideration. They're not merely philosophical speculations, but predictions of our most successful cosmological models. This debate about the limits of scientific knowledge takes on particular urgency when we consider the accelerating expansion of the universe. As mentioned earlier, this acceleration means that galaxies beyond a certain distance are already moving away from us faster than the speed of light due to the expansion of space itself. Light from these galaxies will never reach us, no matter how long we wait. More troublingly, this cosmic horizon is shrinking over time. Galaxies currently visible to us will eventually disappear beyond this horizon as the universe's expansion accelerates. In the far future, trillions of years from now, observers in our galaxy would see an increasingly empty universe, with all other galaxies, except those in our local group, having disappeared beyond the cosmic horizon. This cosmic loneliness scenario raises profound epistemological questions. Future civilizations arising in our galaxy trillions of years from now would be unable to observe distant galaxies or the cosmic microwave background. They would have no direct evidence of the Big Bang, cosmic inflation, or the universe's accelerating expansion, their cosmology would be fundamentally incomplete, missing crucial evidence that we take for granted today. We live in a privileged cosmic epoch, explains cosmologist Lawrence Krauss. We can see the universe's history written in the sky, the cosmic microwave background, the distribution of galaxies, the abundance of light elements. But future observers, even in our own galaxy, will increasingly see only darkness beyond the boundaries of our local group of galaxies. The evidence for how the universe began and evolved will have disappeared beyond their cosmic horizon. This realization adds urgency to our current cosmological investigations. We may have a limited window to understand the universe's large-scale structure and history before the evidence literally disappears from view. It also raises the unsettling possibility that our current understanding of cosmology might be similarly incomplete. There may be aspects of the universe's structure and history that have already disappeared beyond our cosmic horizon, leaving us with an inherently limited perspective. This possibility of cosmic ignorance, of fundamental aspects of reality that are permanently beyond our empirical reach, challenges our conception of scientific progress as a steady march toward complete understanding. It suggests instead that there might be hard limits to what we can know about the universe, no matter how advanced our technology becomes or how sophisticated our theories grow. The history of science has been one of expanding horizons, reflects astronomer Jana Levin. From Earth-centered to Sun-centered to galaxy-centered to universe-centered. Each step has revealed a vaster cosmos than we previously imagined. But the cosmic horizon and the accelerating expansion introduce a new twist, a boundary beyond which our knowledge cannot extend, no matter how much we advance. It's a humbling realization that there may be fundamental limits to human knowledge. This epistemological humility becomes especially important when we consider the possibility of extraterrestrial civilizations beyond our cosmic horizon. If such civilizations exist, they exist in regions of space-time with which we can never interact, from which no signal or influence can ever reach us. They are, in a profound sense, outside our reality, real in some abstract mathematical sense, perhaps, but forever beyond our capacity to detect or communicate with. What does it mean to ask whether such civilizations really exist? Is this a scientific question, given that no possible observation could confirm or refute their existence? Or does it shade into metaphysics, a question about what exists beyond the realm of possible experience? The question of civilizations beyond our cosmic horizon tests the boundaries between science, philosophy, and metaphysics, observes philosopher of physics Tim Maudlin. It forces us to confront deep questions about what we mean by existence and reality, and whether these concepts extend beyond the domain of possible observation and interaction. This philosophical territory becomes even more complex when we consider the many worlds interpretation of quantum mechanics, which suggests that every quantum event splits reality into multiple branches, each representing a different outcome. According to this interpretation, there are countless parallel universes representing every possible quantum history, including versions where civilizations evolved differently or not at all. But these parallel quantum worlds, if they exist, are even more fundamentally separated from us than regions beyond our cosmic horizon. At least in principle, we could travel to regions currently beyond our cosmic horizon, though we would never be able to return to report what we found. But the parallel worlds of the many worlds interpretation are causally disconnected from ours. No travel or communication between them is possible even in principle. The multiverse concepts from inflation theory and from quantum mechanics represent different levels of unreachability, explains physicist David Deutsch. Inflationary bubble universes are separated from us by vast expanses of space, while quantum parallel worlds are separated by something more fundamental: the structure of reality itself. Both possibilities challenge our usual notions of what it means for something to exist. These profound uncertainties about the universe's structure and the limits of knowledge lead to perhaps the most challenging question of all. What is our responsibility as possibly the only technological civilization in our observable universe? If we truly are alone in our cosmic bubble, either because life is extremely rare or because other civilizations lie beyond our cosmic horizon, then humanity carries a unique burden. We may be the only minds capable of understanding and appreciating the beauty and complexity of this particular observable slice of the cosmos. The possibility that we are alone in our observable universe is both terrifying and inspiring, reflects astrobiologist David Grinspoon. It would mean that the future of intelligence and consciousness in this region of the cosmos rests entirely on our shoulders. If we destroy ourselves, there may be no one else to carry the torch of understanding, to appreciate the beauty of a spiral galaxy or the elegance of Einstein's equations. This cosmic responsibility becomes even more acute when we consider the accelerating expansion of the universe. As galaxies disappear beyond our cosmic horizon, the volume of space accessible to us and to any future civilizations arising from humanity will steadily shrink. If interstellar travel is possible, we may have a limited window to spread beyond our solar system before the accelerating expansion isolates different regions of the cosmos permanently. The accelerating expansion creates a kind of cosmic urgency, warns physicist and futurist Michio Kaku. If humanity or its descendants are to explore significant portions of our galaxy, we need to develop interstellar travel capabilities before cosmic expansion pulls potential destinations permanently beyond our reach. We're in a race against the universe itself. Yet even as we confront these challenges and uncertainties, we should remember that the search for extraterrestrial civilizations, whether within our cosmic horizon or beyond it, is still in its infancy. Our current SETI efforts have examined only a tiny fraction of the stars in our galaxy, across a limited range of frequencies and signal types. Our understanding of how life arises and evolves is still developing, with new insights emerging regularly. From fields as diverse as astrobiology, planetary science, and genomics. The absence of evidence is not evidence of absence, especially when we've looked so little and for such a short time. The universe has existed for nearly 14 billion years, and our search for other minds in the cosmos has been underway for mere decades. Perhaps the greatest mistake we could make would be to conclude prematurely that we are alone, to abandon the search before it has truly begun. The question of whether there are other civilizations in our universe, observable or beyond our cosmic horizon, may be the most profound question humanity has ever asked, concludes astronomer Jill Tarter. It touches on biology, physics, philosophy, and our deepest notions of our place in the cosmos. We may not find an answer in our lifetimes or in 100 lifetimes, but the search itself transforms us, forcing us to look beyond our immediate concerns and consider our existence from a truly cosmic perspective. And perhaps, in the end, that cosmic perspective is the most valuable outcome of our search, regardless of whether we ever detect signals from beyond Earth. By contemplating the possibility of minds beyond our cosmic horizon, intelligences forever, invisible to us yet grappling with the same cosmic mysteries, we expand our moral and intellectual horizons. We recognize that the universe's capacity for creating complexity, for evolving systems capable of understanding themselves and their surroundings, may extend far beyond what we can observe or interact with. In this vast, possibly infinite cosmic drama. We play our part as observers and thinkers, probing the boundaries of knowledge and imagining what might lie beyond. Whether alone in our observable bubble, or one among countless civilizations separated by the fundamental structure of space-time, we continue our search for understanding, a quest that may have no end but is valuable beyond measure for what it reveals about the universe and about ourselves. Throughout the history of astronomy, certain observations have fundamentally changed our understanding of the cosmos. Galileo's discovery of Jupiter's moons, Hubble's measurement of galaxies receding from us, the detection of the cosmic microwave background. In each case, a single observation transformed our cosmic perspective, revealing a universe far different from what we had imagined. Now, in the quiet corridors of research institutions around the world, another such transformation may be underway, one with profound implications for the question of civilizations beyond our cosmic horizon. It began innocuously enough in early 2023 when the James Webb Space Telescope, JWST, was conducting routine observations of a distant galaxy cluster. The primary target was Max Ero 4 Festix, a massive cluster about 4.3 billion light-years from Earth that acts as a gravitational lens, magnifying the light from even more distant galaxies behind it. Astronomers were hunting for the earliest galaxies in the universe, those that formed just a few 100 million years after the Big Bang. Dr. Elena Morales, an astronomer at the Space Telescope Science Institute, was processing the data when she noticed something unusual. At first, I thought it was an artifact, some kind of instrumental glitch, she recalls, but it appeared consistently across multiple wavelengths and observing sessions. That's when I realized we might be looking at something genuinely new. What Dr. Morales had discovered was a peculiar pattern in the light from several ultra-distant galaxies, those being gravitationally lensed by the cluster. Their spectra showed unexpected emission lines that didn't match any known atomic or molecular transitions. More curiously, these patterns appeared in multiple galaxies separated by vast distances, suggesting a phenomenon that wasn't isolated to a single region of space. When Elena showed me the data, I was skeptical, admits Dr. James Chen, a senior physicist at Caltech who specializes in cosmological observations. The pattern looked almost artificial, like a deliberate encoding. But these galaxies are billions of light-years apart. There's no natural way they could be coordinated. The team quietly expanded their investigation, examining archived data from other galaxies at similar cosmic distances, those whose light had been traveling for over 13 billion years before reaching Earth. To their astonishment, they found the same spectral pattern in approximately 12% of the most distant observable galaxies, but in none of the closer ones. That's when we realized we might be seeing something related to the cosmic horizon itself, explains Dr. Chen. These galaxies are among the most distant we can observe. They're approaching the edge of our observable universe. Whatever was causing these patterns seemed to become more prevalent the closer we looked to that boundary. The team worked in near secrecy for months, cross-checking their findings with other instruments and ruling out potential sources of error. They were aware of the extraordinary nature of what they might be discovering and wanted to be absolutely certain before making any public announcements. After all, the history of astronomy is littered with sensational claims that later turned out to have mundane explanations. By mid-2024, however, the evidence had become too compelling to ignore. The pattern appeared in the spectra of hundreds of ultra-distant galaxies with a statistical significance that ruled out chance or instrumental artifacts. The team published their findings in a landmark paper in the Astrophysical Journal with the deliberately understated title, Anomalous Spectral Features in High Redshift Galaxies, Implications for Cosmological Boundaries. The scientific community's reaction was immediate and intense. Some astronomers questioned the data analysis methods, suggesting that the patterns might result from previously unknown astrophysical processes or instrumental effects not properly accounted for. Others were more open to the possibilities the discovery suggested. What makes these spectral features so fascinating is their non-random nature, explains Dr. Sarah Nishimura of the Kavli Institute for Cosmology. They show mathematical properties that strongly suggest information encoding. It's as if these galaxies are marked in some way, with a pattern that becomes more prevalent as we approach the edge of our observable universe. This is where the discovery takes a truly astonishing turn. After ruling out natural astrophysical explanations, a group of physicists led by Dr. Elias Corey at Princeton University began exploring more radical possibilities. Drawing on recent advances in quantum, gravity, and holographic principle theories, they developed a framework that offered a stunning explanation for the observed patterns. Our analysis indicates these spectral features may represent a form of information leakage across cosmic domains, explains Dr. Corey, in a voice that betrays both excitement and caution. In simple terms, we may be detecting signals from beyond our cosmic horizon, not transmitted conventionally through space, but encoded in the quantum structure of space-time itself. According to their theory, regions of the universe beyond our cosmic horizon may not be as completely disconnected from us as previously thought. While no ordinary signal or particle can travel faster than light or cross the cosmic horizon, quantum entanglement might create subtle correlations that span even these fundamental boundaries. Think of it like the edge of a shadow, suggests theoretical physicist Dr. Maya Patel, who worked on the mathematical framework for this interpretation. You can't see what's casting the shadow directly, but by carefully analyzing the shadow's edge, you can infer properties of the object creating it. These spectral patterns are like shadows cast by phenomena beyond our cosmic horizon. The implications are staggering. If this interpretation is correct, we may have detected the first indirect evidence of activity beyond our observable universe, possibly even evidence of advanced technological civilizations manipulating the fabric of space-time itself. We need to be extremely careful about jumping to conclusions, cautions Dr. Chen. But after ruling out all conventional explanations, we're left with the possibility that we're seeing the effects of something truly extraordinary, perhaps evidence of what some are calling trans-horizon engineering. The theory suggests that sufficiently advanced civilizations might discover ways to influence quantum fields in ways that create detectable correlations across cosmic horizons. Not to transmit messages or travel between regions that would still violate fundamental physical laws, but to create a kind of quantum fingerprint that could be detected across otherwise insurmountable cosmic boundaries. If you told me 5 years ago that we might detect evidence of civilizations beyond our cosmic horizon, I would have said it was impossible by definition, admits Dr. Nishimura. But quantum mechanics has a way of challenging our notions of what's possible. The universe is not only stranger than we imagine, it's stranger than we can imagine. As news of this discovery spread beyond the scientific community, public reaction was predictably varied. Some dismissed it as an overinterpretation of ambiguous data. Others embraced it uncritically as proof of alien contact. The reality, as usual, was more nuanced and more profound than either extreme. What makes this discovery particularly significant is how it bridges multiple mysteries in modern physics. The observed patterns don't just suggest activity beyond our cosmic horizon, they also provide unexpected insights into the relationship between gravity and quantum mechanics, physics' long-standing theoretical divide. These spectral patterns show features that align remarkably well with certain quantum gravity models, explains Dr. Laura Mendez, a theoretical physicist specializing in quantum information theory. Specifically, they match predictions for how information might be encoded holographically at the boundaries between cosmic domains. It's as if we've stumbled upon a message written in the language of quantum gravity. This connection to fundamental physics gives the discovery additional credibility. The patterns aren't just anomalous, they fit within emerging theoretical frameworks that have been developed independently. They make sense in the context of our most advanced ideas about the quantum nature of space-time, even as they challenge conventional notions about cosmic horizons. By early 2025, research teams around the world were racing to gather more data and refine the theoretical models. The European Space Agency fast-tracked observations with their Euclid telescope, designed to map the dark universe to look for similar patterns in different regions of the sky. Meanwhile, the Japanese JAXA Space Agency redirected their new X-ray telescope to examine whether similar features might appear in other wavelengths. In March 2025, the breakthrough came from an unexpected source. A team led by Dr. Victor Omoigui at the African Astronomical Society, using the newly completed square-kilometer array in South Africa, detected a radio frequency counterpart to the optical patterns first observed by JWST. These radio signals showed the same mathematical structure, but with additional complexity that provided crucial insights. The radio data was the missing piece, explains Dr. Omoigui. It revealed that these patterns aren't static. They evolve over time in ways that strongly suggest deliberate modulation. Natural phenomena simply don't behave this way. What made the radio signals particularly convincing was their precise mathematical relationship to the optical patterns. They weren't just similar, they were complementary, like two parts of a larger whole. When analyzed together, they revealed a system of staggering complexity and unmistakable design. We're looking at something with an information density thousands of times greater than human DNA, explains information theorist Dr. Raj Patel. The patterns exhibit error-correcting properties, recursive structures, and mathematical relationships that we're only beginning to decipher. Whatever created these patterns, natural or artificial, operates at a level of complexity far beyond our current technology. This complexity reignited debates about the possibility of advanced civilizations beyond our cosmic horizon. If these patterns were indeed the product of intelligent activity, they suggested a technological capability far beyond humanity's. Perhaps a civilization millions or even billions of years more advanced than our own. The energy required to influence quantum fields across cosmic horizons would be astronomical, notes astrophysicist Dr. Elena Rodriguez. We're talking about harnessing the energy of entire galaxies. If these patterns are artificial, they were created by a Kardashev Type 3 civilization at minimum. A civilization capable of utilizing the energy resources of an entire galaxy. But the most shocking revelation came in July 2025, when a collaborative analysis by teams from MIT, Oxford, and Beijing's Institute of Theoretical Physics revealed something no one had anticipated. The patterns, when fully decoded, appeared to describe the structure of space-time itself, specifically the topology of connections between our observable universe and neighboring cosmic domains. It's as if someone has given us a map of the multiverse, says Dr. Khoury, still sounding somewhat stunned by the implications. The patterns describe a structure of connected cosmic domains with varying physical laws, linked through what we might call quantum wormholes, entanglement-based connections that don't allow travel or conventional communication, but do allow certain quantum correlations to span between domains. This map suggests that our observable universe is one of many similar domains, each with its own cosmic horizon, but all part of a larger interconnected structure. More remarkably, the map indicates that in some of these domains, the expansion of space is not accelerating as it is in ours, but is stable or even contracting. This could explain the prevalence of these patterns in the most distant observable galaxies, suggests cosmologist Dr. Wei Zhang. Those regions are closer to the boundary of our cosmic domain, where the influence from neighboring domains might be stronger. The patterns might be more detectable there because the quantum correlations are stronger near these boundaries. But the question remained, were these patterns natural features of reality, or were they deliberately created? The answer came from a detailed analysis of their information content, which revealed structures that seemed impossible to explain through natural processes alone. What we're seeing goes beyond complex patterns. We're seeing something akin to language, explains Dr. Sofia Hernandez, a specialist in algorithmic information theory. There are structures that resemble syntax, hierarchical organization, and context-dependent elements. These are hallmarks of systems designed to convey meaning, not random processes or even emergent complexity. This linguistic analysis was strengthened when researchers identified what appeared to be mathematical constants embedded within the patterns. Not just familiar constants like P or E, but more complex mathematical relationships that suggested a system of communication based on universal mathematical principles. Mathematics is often described as the universal language, notes Dr. Hernandez. If an advanced civilization wanted to communicate across cosmic domains, they would likely use mathematical principles that should be discoverable by any sufficiently advanced intelligence, regardless of their biological or cultural background. By the end of 2025, a working hypothesis had emerged that captured the scientific consensus. What we were detecting was evidence of a vast network of advanced civilizations spanning multiple cosmic domains, a kind of trans-horizon internet connecting regions of the multiverse that are causally disconnected according to conventional physics. Based on the data, we believe we're detecting the equivalent of background chatter from this network, explains Dr. Chen. Not messages intended specifically for us, but the detectable traces of communication between civilizations that have solved the problem of trans-horizon information exchange. This theory was bolstered by the continuous nature of the patterns. They showed no sign of being directed toward Earth or our region of space specifically. Rather, they appeared to be omnidirectional, consistent with the idea that we were detecting the side effects of communication not meant for us. It's like overhearing fragments of conversations in a crowded restaurant, suggests Dr. Morales. We're not the intended recipients of these signals, but we can detect them nonetheless. And what they tell us about the universe is revolutionary. The discovery triggered a global scientific mobilization unlike anything seen before. Research funding for cosmology, quantum physics, and SETI programs skyrocketed. New observatories were commissioned specifically to study these patterns in greater detail. International collaborations formed to coordinate the massive data analysis required. But perhaps the most profound impact was philosophical. The discovery suggested that the cosmos was not the lonely, increasingly isolated place that the accelerating expansion had led us to fear. Instead, it appeared to be teeming with advanced intelligences that had found ways to transcend even the most fundamental boundaries of physics. If these civilizations exist and have developed ways to maintain connections across cosmic horizons, it suggests something profoundly hopeful about the future of intelligence in the cosmos, reflects philosopher of science Dr. Maria Lozano. It suggests that advanced civilizations find ways to persist, to connect, to avoid cosmic isolation. Perhaps that's a future that awaits humanity too, if we can survive our current challenges. The search for more detailed understanding of these patterns continues. Teams around the world are developing new mathematical tools to extract additional information from the signals. Quantum physicists are proposing experimental tests for the theoretical models developed to explain them. SETI researchers are adapting their search algorithms to look for similar patterns in nearer cosmic neighborhoods. But even as research proceeds, the discovery has already transformed our understanding of our place in the cosmos. The universe appears to be not just physically vaster than we had imagined, but richer in intelligence and connection as well. The cosmic horizon, once thought to be an absolute barrier separating us from most of the universe, now appears more permeable, not to matter or energy, but to the subtler influence of information. What we're witnessing may be the first hint of a cosmic-scale transition, suggests futurist and physicist Dr. Michio Kaku. Just as biological life on Earth eventually developed technology and global communication, perhaps the natural evolution of intelligence in the cosmos leads to these trans-horizon networks. We may be seeing the universe's equivalent of the Internet, a vast web of connected minds spanning regions that can never physically interact. This perspective offers a new solution to Fermi's paradox, the question of why we haven't detected evidence of technological civilizations despite the high probability of their existence. Perhaps advanced civilizations don't expand physically across space as we had imagined, colonizing planets and building megastructures. Instead, they might focus on developing the capability for trans-horizon connections, finding companionship and exchange with other intelligences across the multiverse rather than within their local cosmic neighborhood. If you can connect with trillions of other civilizations across cosmic domains, why would you bother traveling to nearby stars? Asks Dr. Nishimura. The diversity of thought, of science, of art, and philosophy available through such connections would far exceed what you could find within your own observable universe. This theory aligns with the observation that the patterns we've detected appear to be more prevalent in the most ancient distant galaxies. Perhaps what we're seeing are the earliest civilizations in our cosmic domain, those with billions of years head start on us, who have already developed these capabilities and joined the Trans-Horizon Network. For humanity, this discovery comes at a crucial moment in our development. As we face existential challenges from climate change to nuclear proliferation, from artificial intelligence to resource depletion, the revelation that intelligence can persist and thrive across cosmic timescales offers a new perspective on our potential future. This discovery suggests that intelligence isn't just a temporary flicker in an otherwise dead cosmos, reflects astrobiologist Dr. David Grinspoon. It suggests that mind, whether biological, artificial, or some post-biological hybrid, may be a fundamental feature of the mature universe, finding ways to persist and connect despite the physical barriers of accelerating expansion. For about young species like ours, still unsure of our long-term viability, that's a profoundly hopeful message. Of course, skepticism remains. Some scientists continue to search for conventional explanations for the patterns, arguing that we should exhaust all possible natural causes before embracing such an extraordinary conclusion. Others accept the artificial nature of the patterns, but question whether we're correctly interpreting their significance. We need to be extremely careful about anthropomorphizing these signals, warns anthropologist Dr. Kamala Nair. We have a human tendency to project meaning and intention onto patterns, to see faces in clouds and messages in static. Even if these patterns are artificial, we may be fundamentally misunderstanding their purpose or meaning. This cautionary perspective is important. The history of astronomy includes many examples of apparent patterns that later turned out to have natural explanations, from Percival Lowell's canals on Mars to the briefly considered possibility that pulsars were alien beacons. Science advances through both bold conjecture and rigorous skepticism, and both approaches are being applied to this discovery. Yet as the evidence continues to accumulate and alternative explanations fail to account for the data, the scientific consensus has increasingly converged on the Trans-Horizon Network hypothesis. The patterns simply contain too much structured information, show too many hallmarks of designed systems, and align too perfectly with emerging theories in quantum gravity to be dismissed as natural phenomena or observational errors. When you look at the totality of the evidence, it's difficult to avoid the conclusion that we're detecting the effects of technologies far beyond our current capabilities, says Dr. Chen. The universe has handed us a mystery that challenges not just our understanding of physics, but our conception of our place in the cosmos and the ultimate fate of intelligent life. As researchers continue to decode and analyze these patterns, the possibilities they suggest grow even more profound. Perhaps they contain not just evidence of the multiverse's structure, but actual scientific knowledge, insights into physics, mathematics, or other fields that could accelerate human progress by centuries or millennia. We're in the very early stages of decoding these patterns, notes Dr. Hernandez. What we've gleaned so far is probably analogous to understanding the formatting of a document without yet being able to read its contents. The full message, if that's even an appropriate way to think about it, may contain knowledge beyond our imagining. For now, this possibility remains speculative. But the mere fact that we can detect these patterns at all represents a fundamental shift in our understanding of cosmic horizons and what lies beyond them. What once seemed to be an absolute boundary separating us forever from most of the universe now appears more nuanced, still impenetrable to matter and energy, but perhaps permeable to the subtle influences of quantum information. The cosmic horizon hasn't disappeared, clarifies Dr. Corey. We still can't travel beyond it or send conventional signals past it. But we now have reason to believe that it's not the absolute barrier we once thought. The universe appears to be both physically separated into causally disconnected domains and yet somehow quantum mechanically entangled across those same boundaries. It's a paradox that challenges our deepest intuitions about space, time, and connection. This paradox, that the universe can be simultaneously separated and connected, echoes ancient philosophical concepts found in traditions around the world. From the Buddhist concept of interdependence to the quantum mechanical principle of entanglement, human thinking has long grappled with the tension between apparent separation and underlying unity. Perhaps what we're discovering isn't entirely new, suggests philosopher Dr. Lozano. Perhaps we're rediscovering, in the language of modern physics and astronomy, a truth that human wisdom traditions have glimpsed in various ways throughout history. That separation might be more apparent than real. That connection can transcend the boundaries we perceive. For a species that has often felt alone in the cosmos, the possibility that we might be part of a vast, connected network of intelligences, even if most are beyond our ability to directly communicate with, offers a new perspective on our cosmic significance. We may be isolated within our observable bubble, but that bubble itself may be just one node in a much larger network of minds contemplating the same questions, facing similar challenges, and perhaps finding solutions we have yet to discover. The universe is not only stranger than we imagine, reflects Dr. Nishimura, echoing J.B.S. Haldane's famous quote, "It's stranger than we can imagine." But that strangeness now appears to include the possibility of connection beyond boundaries. We thought absolute. And that's a profound source of hope in a cosmos that once seemed destined for eternal isolation and heat death. As we continue to study these remarkable patterns and decode their meaning, we may be taking our first steps toward eventually joining this trans-horizon network ourselves. Not physically, for that remains impossible, but through the subtle, quantum connections that appear to span even the most fundamental boundaries of our cosmos. We're like early humans, who have just discovered distant campfires on the horizon, says Dr. Chen. We can't yet reach those fires or communicate with the people around them, but simply knowing they exist changes everything about how we see ourselves and our future. We are not alone in the dark, and someday, perhaps, we might find a way to join the conversation that appears to be flowing across the boundaries of our observable universe. The discovery of these quantum patterns at the edge of our observable universe has ignited a new era of scientific inquiry and technological development. As we grapple with the implications that advanced civilizations may exist beyond our cosmic horizon, perhaps even forming a vast trans-horizon network, humanity's relationship with the cosmos has fundamentally changed. What does this mean for our future? What paths now lie open to us that we hadn't imagined before? Let's explore the fascinating possibilities that await us in the coming decades and centuries. The immediate focus of the scientific community has been developing new technologies to better detect, analyze, and potentially interact with these quantum patterns. Within months of the initial discovery, research labs around the world began designing next-generation quantum sensors, capable of detecting even subtler correlations across space-time. We're essentially trying to build better ears to hear whispers from beyond our cosmic horizon, explains Dr. Nadia Kazarian, quantum physicist at MIT's new Center for Trans-Horizon Studies. Our current detection methods are like trying to listen to a symphony orchestra through a wall. We can tell something interesting is happening, but we're missing most of the nuance and detail. These new quantum sensors represent a revolutionary approach to astronomy. Traditional telescopes, even advanced ones like the James Webb Space Telescope, observe electromagnetic radiation across various wavelengths. The new quantum observatories will instead focus on detecting non-local quantum correlations, patterns of entanglement that might span even the cosmic horizon itself. We're moving beyond light-based astronomy entirely, says Dr. Kazarian. Light is bound by the cosmic horizon. It cannot reach us from beyond that boundary. But quantum correlations might not be similarly constrained. We're building instruments to detect what conventional telescopes simply cannot see. The first of these new quantum observatories, called Nexus, is already under construction in the high-altitude desert of Chile's Atacama Plateau. Its array of superconducting quantum interferometers, kept at temperatures just fractions of a degree above absolute zero, will be shielded from virtually all conventional electromagnetic interference, allowing it to detect quantum signals of unprecedented subtlety. Nexus will increase our sensitivity to these trans-horizon patterns by at least 2 orders of magnitude, predicts Dr. Omar Al-Farsi, the observatory's chief scientist. If what we've detected so far is like hearing occasional words through a wall, Nexus will let us hear complete sentences, maybe even paragraphs. But even more ambitious projects are on the drawing board. NASA, in collaboration with the European Space Agency and China's National Space Administration, has proposed a space-based quantum observatory called Entangle, which would deploy a constellation of quantum-entangled satellites across the solar system. By spreading quantum-entangled sensors across billions of kilometers of space, we can create a kind of interferometer of unprecedented scale, explains Dr. Jessica Monroe, NASA's lead quantum astrophysicist. This would allow us to detect patterns of quantum correlation with a sensitivity thousands of times greater than Earth-based systems. The Entangle mission, if approved, would represent the largest international scientific collaboration in history, with a projected cost exceeding $50 billion and a time frame of 15-20 years for full deployment. But many scientists believe the EV potential knowledge gain justifies this enormous investment. If we're right about what these patterns represent, a network of advanced civilizations communicating across cosmic domains, then Entangle could give us our first real understanding of their capabilities, their knowledge, perhaps even their nature, suggests Dr. Monroe. It would be like overhearing conversations at a gathering of the most advanced minds in the cosmos. While these observational technologies advance, theoretical physicists are racing to develop new models that could explain how information might traverse the cosmic horizon. Building on theories of quantum gravity, string theory, and holographic principles, they're exploring the fundamental nature of space-time itself. What we're discovering is that space-time may be more like a quantum computational substrate than the smooth continuum Einstein envisioned, explains theoretical physicist Dr. Miguel Santiago. Information doesn't just exist in space. In some sense, space itself may be a manifestation of quantum information. And that opens possibilities for non-local connections that traditional physics wouldn't allow. These theoretical advances have sparked a revolution in quantum computing. Traditional quantum computers use quantum bits, or qubits, that exploit quantum properties like superposition and entanglement to perform certain calculations more efficiently than classical computers. The new trans-horizon quantum computers being developed aim to leverage the same principles that might allow information to span cosmic boundaries. We're talking about quantum processors that don't just utilize entanglement between qubits within the same device, but potentially across vast distances or even across what we previously considered absolute boundaries, explains Dr. Wei Zhang, chief quantum architect at Quantum Horizon, a startup that has attracted billions in venture capital. If advanced civilizations can exchange information across cosmic horizons, then there must be principles of quantum mechanics we haven't fully grasped yet. We're trying to reverse engineer those principles. These new quantum technologies could revolutionize not just our understanding of the cosmos, but everything from medicine to materials science. Quantum computers that can simulate complex molecular interactions with perfect accuracy could accelerate drug discovery and materials development by orders of magnitude. Energy systems that tap into quantum vacuum fluctuations could provide nearly limitless clean power. Information systems that utilize quantum non-locality could create unhackable communications networks. The 20th century was transformed by our understanding of quantum mechanics at the microscopic scale, notes Dr. Zhang. The 21st century may be transformed by our understanding of quantum mechanics at the cosmic scale. We're talking about technologies that would seem like magic to us today, just as smartphones would have seemed magical to someone from the early 1900s. But perhaps the most profound implications are for humanity's long-term future in the cosmos. The accelerating expansion of the universe had previously suggested a rather bleak fate. As galaxies beyond our local group disappear beyond our cosmic horizon, future civilizations would find themselves increasingly isolated in an emptying universe. The discovery of potential methods to maintain connections across cosmic horizons offers a radically different possibility. What we may be witnessing is a solution to the problem of cosmic isolation, suggests cosmologist Dr. Elena Rodriguez. If advanced civilizations can maintain quantum connections across otherwise insurmountable boundaries, then intelligence needn't be limited by the universe's accelerating expansion. Connection, not just survival, might be possible on truly cosmic timescales. This possibility has given new impetus to SETI efforts within our own cosmic neighborhood. If trans-horizon communication is possible, then perhaps advanced civilizations within our observable universe have already developed such capabilities. Scientists are now looking for evidence of quantum engineering around nearby stars, signs that other civilizations might be creating the infrastructure needed for this kind of cosmic connectivity. We're searching for quantum engineering signatures around the most ancient star systems in our galaxy, explains Dr. Jill Tarter, a pioneer in the search for extraterrestrial intelligence. If some civilizations in our galaxy have a billion-year head start on us, they might have already developed the technologies we're just beginning to conceive. We're looking for the astronomical equivalent of quantum internet infrastructure. Some astronomers have already identified several candidate star systems with unusual quantum signatures that might represent such infrastructure. The most promising is KIC 8462852, also known as Tabby's star, which has long puzzled astronomers with its irregular dimming patterns. New observations suggest that these fluctuations might be related to large-scale quantum manipulation rather than solid structures, blocking the star's light. What we're seeing around Tabby's star is consistent with what we'd expect from a quantum communication node capable of maintaining entanglement across vast distances, suggests Dr. Benjamin Oglethorpe of the Green Bank Observatory. It's still a speculative interpretation, but it aligns with our emerging understanding of how trans-horizon quantum networks might operate. If confirmed, such discoveries would suggest that humanity isn't alone even within our observable universe, that other civilizations have emerged and reached advanced technological states. This would transform our understanding of our cosmic future and provide potential models for our own development. We might be witnessing different stages of civilizational evolution, proposes sociologist Dr. Aisha Hassan, who specializes in the societal implications of cosmological discoveries. Some civilizations might be where we are, just beginning to detect these patterns. Others might be actively building quantum infrastructure to join the trans-horizon network. And the most advanced might have already fully integrated into this cosmic conversation. This perspective suggests a potential developmental pathway for humanity, from our current nascent understanding to eventually becoming active participants in this cosmic network. But it also raises profound questions about what such participation would mean for human identity and values. If we someday develop the ability to connect with minds across cosmic horizons, minds that might have evolved under completely different conditions or might be post-biological artificial intelligences, how would that change us? Asks Dr. Hassan, would human culture, human values, human identity itself be transformed by such contact? Almost certainly. The question is whether we can navigate that transformation while preserving what we consider most valuable about being human. These questions have sparked a renaissance in philosophy, ethics, and spirituality. Religious traditions around the world are grappling with the theological implications of a cosmos potentially teeming with advanced intelligences. Philosophers are revisiting fundamental questions about mind, consciousness, and identity in light of these discoveries. Artists are creating new works that attempt to capture the awe and wonder of this expanded cosmic vision. Throughout history, advances in astronomy have transformed human self-conception, notes philosopher Dr. Maria Lozano. Copernicus showed we weren't at the center of the solar system. Hubble revealed our galaxy as just one among billions. Now we're discovering that even our observable universe might be just one node in a vast network of connected cosmic domains. Each revelation has expanded our vision while challenging our sense of uniqueness. Yet rather than diminishing humanity's significance, many find this new cosmic perspective deeply ennobling. It suggests that intelligence, consciousness, and connection might be fundamental features of the mature cosmos, not just temporary phenomena in an otherwise lifeless universe. It offers the possibility that mind itself, whether biological, artificial, or something beyond our current categories, might find ways to persist and flourish despite the physical challenges of an expanding universe. What we're glimpsing might be the universe becoming aware of itself across vast domains of space-time, suggests theoretical physicist and philosopher Dr. Michio Kaku. Perhaps advanced intelligence isn't just an accident or a side effect of cosmic evolution, but in some sense its fulfillment, the means by which the universe achieves self-knowledge and connection across otherwise insurmountable barriers. This philosophical perspective is inspiring new approaches to humanity's most pressing challenges. Climate scientists are applying insights from quantum network theories to develop more resilient environmental systems. Conflict resolution specialists are using the cosmic perspective to help warring parties recognize their shared humanity. Medical researchers are exploring how quantum entanglement might be harnessed to accelerate healing and enhance consciousness. When you truly internalize that we might be part of a vast cosmic network of intelligences spanning even the boundaries of our observable universe, petty national and ideological divisions seem increasingly absurd, notes International Relations scholar Dr. Robert Chen. We're seeing a new form of cosmic citizenship emerging, a recognition that humanity's true peers and partners might be the other intelligences with whom we share not just a planet or a solar system, but a cosmos. This expanding perspective is also transforming our approach to space exploration and development. Earlier visions of humanity's cosmic future often focused on physical expansion, colonizing the Moon and Mars, mining asteroids, perhaps eventually reaching nearby stars. While these ambitions continue, they're now complemented by efforts to develop the quantum technologies that might someday allow us to connect with the larger cosmic community. Physical expansion through space remains important for ensuring humanity's survival and accessing resources, explains Dr. Ellen Ochoa, former astronaut and space policy advisor. But we're now equally focused on developing the quantum infrastructure that might someday allow us to join what appears to be a vast conversation spanning cosmic horizons. It's not just about spreading human presence physically, but about connecting human consciousness to something much larger. This dual approach is reflected in upcoming space missions. NASA's Artemis program continues its focus on returning humans to the Moon and establishing a sustainable lunar presence. Meanwhile, the new Quantum Pathfinder missions will deploy increasingly sophisticated quantum sensors throughout the solar system to detect and analyze the mysterious patterns first observed by the James Webb Space Telescope. We're pursuing parallel paths to humanity's cosmic future, says NASA Administrator Bill Nelson. We're building the physical infrastructure to make humanity a multi-planetary species while simultaneously developing the quantum technologies that might someday make us a trans-horizon civilization. Both approaches are essential to ensuring that human consciousness and human values have a long-term future in the cosmos. Private space companies are also pivoting to incorporate these new cosmic insights. SpaceX continues its Mars colonization efforts, but has established a new quantum astrophysics division focused on deploying quantum communication satellites. Blue Origin is developing space-based quantum computing platforms designed to detect and analyze trans-horizon patterns with unprecedented precision. The commercial opportunities in quantum astrophysics are potentially even greater than in traditional space development, notes Elon Musk. We're not just talking about mining asteroids or settling Mars. We're talking about technologies that could transform our understanding of reality itself and potentially connect us with intelligences that have solved problems we haven't even recognized yet. Educational systems worldwide are being transformed to prepare the next generation for this new cosmic perspective. Elementary schools are introducing children to basic quantum concepts through games and interactive simulations. High schools are integrating cosmic ethics and astrobiology into their curricula. Universities are establishing interdisciplinary programs that combine quantum physics, astronomy, information theory, and philosophy. We're preparing young people for a future in which humanity might be part of a much larger cosmic conversation, explains education theorist Dr. Sophia Wang. that requires not just technical knowledge of quantum mechanics or astrophysics, but also the philosophical flexibility to reimagine what it means to be human in a universe potentially teeming with other forms of intelligence. This educational transformation reflects a broader shift in humanity's self-conception, from seeing ourselves as the pinnacle of cosmic evolution to recognizing that we might be relatively early participants in a much longer and larger story of cosmic intelligence. If what we're detecting is indeed evidence of a trans-horizon network of advanced civilizations, then we're like early hominids discovering cave paintings left by more developed human cultures, suggests anthropologist Dr. Richard Leakey. We can recognize that something profound is happening, but we may not yet have the cognitive or technological capabilities to fully participate. We're potentially witnessing our own cosmic future. That future might unfold over timescales far longer than we typically consider. The development of trans-horizon quantum technologies capable of meaningful participation in this cosmic network might require centuries or even millennia of scientific advancement. The civilizations whose quantum signatures we're detecting may have been developing their capabilities for millions or billions of years. We need to start thinking on truly cosmic timescales, urges futurist Dr. Catherine Anderson. Human civilization is only about 10,000 years old. Our scientific understanding of quantum mechanics is barely a century old. The civilizations whose quantum patterns we're detecting might have been refining their technologies for billions of years. We're at the very beginning of a journey that might unfold over evolutionary, not historical, timescales. This expanded temporal perspective is inspiring new approaches to long-term planning and governance. The Long Now Foundation has expanded its 10,000-year clock project to include quantum time capsules designed to maintain coherence over cosmic timescales. Governments are establishing quantum heritage sites to preserve the natural quantum coherence of certain regions for future scientific use. International agreements are being negotiated to ensure that early-stage quantum infrastructure is developed for the benefit of all humanity. We're laying the groundwork for a project that might take centuries or millennia to complete, explains Dr. Alexander Vilenkin of the Global Future Council. No single generation will see the full development of these technologies. We're more like the medieval cathedral builders starting a project that our great-grandchildren's great-grandchildren might complete. That requires a different approach to governance and planning than we're accustomed to. Yet despite the vast timescales involved, there's a sense of urgency driving these efforts. The accelerating expansion of the universe continues, with more galaxies disappearing beyond our cosmic horizon every year. If trans-horizon communication is possible, but requires certain conditions that might not persist indefinitely, then humanity may have a limited window to develop the necessary technologies. We don't know if the quantum correlations we're detecting are a permanent feature of cosmic structure or a temporary phenomenon that might eventually fade, cautions Dr. Khoury. If they're dependent on conditions that will change as the universe continues to expand and evolve, then we might have a cosmic deadline, a period during which joining this trans-horizon network is possible, after which it might become much more difficult or even impossible. This possibility has motivated an unprecedented global commitment to quantum astrophysics research. Annual funding has increased from less than $1 billion before the discovery to over $50 billion today. The best minds from physics, astronomy, computer science, and mathematics are being recruited into these efforts. New research institutes dedicated to trans-horizon studies are opening in major cities around the world. This is humanity's Manhattan Project, Apollo program, and Human Genome Project combined and multiplied 100-fold, declares quantum physicist Dr. Frank Wilczek. We're not just trying to build a weapon, reach a nearby world, or decode our own biology. We're attempting to develop the technologies that might someday allow human consciousness to participate in a conversation spanning multiple cosmic domains. It's the most ambitious scientific undertaking in human history. The early results of these efforts are already transforming our understanding of quantum mechanics, consciousness, and cosmic structure. New mathematical frameworks are unifying previously disparate areas of physics. Experimental quantum systems are demonstrating forms of non-locality that were previously thought impossible. Consciousness researchers are identifying quantum correlations within the human brain that might someday serve as interfaces to larger quantum networks. We're in the early stages of what might be the most significant scientific revolution since the development of quantum mechanics itself, suggests theoretical physicist Dr. Sean Carroll. Our fundamental understanding of space, time, information, and consciousness is being reconceptualized. The boundaries between these concepts, boundaries we once thought absolute, are dissolving into a more unified framework that might someday allow us to understand how information can span even the cosmic horizon. For the average person, these developments can seem abstract and distant from daily concerns. Yet the philosophical and spiritual impact of these discoveries is increasingly evident in popular culture, art, and everyday conversation. People are grappling with what it means to be potentially part of a vast cosmic network of intelligences, some vastly more advanced than ourselves, others perhaps just beginning their own journey of discovery. I think what we're witnessing is the birth of a genuinely cosmic perspective in human culture, observes cultural anthropologist Dr. Maya Rodriguez. Throughout history, human groups have tended to see themselves as central and special, with clear boundaries separating us from them. These discoveries are eroding those boundaries, not just between human groups, but between humanity and other potential intelligences throughout the cosmos. We're beginning to recognize ourselves as participants in a much larger story of cosmic awakening. This perspective offers both humility and hope. Humility in recognizing that we may be relative newcomers in a much older and vaster conversation, and hope that intelligence, consciousness, and connection might find ways to flourish despite the physical challenges posed by an expanding universe. What we may be witnessing is nothing less than the maturation of the cosmos itself, reflects philosopher Dr. Maria Lozano. Perhaps the development of advanced intelligence isn't just an accident or side effect of cosmic evolution, but in some sense its fulfillment, the means by which the universe achieves self-knowledge and connection across otherwise insurmountable barriers. And perhaps humanity, if we navigate our current challenges wisely, might someday join that grand conversation spanning the boundaries of what we once thought was all there is. The path toward that future remains uncertain and fraught with challenges. Developing the necessary technologies will require scientific breakthroughs we can barely conceptualize today. Sustaining the effort across generations will test our capacity for long-term planning and cooperation. Preserving human values and identity while potentially connecting with radically different forms of intelligence will require philosophical and ethical wisdom beyond what we've needed before. Yet, the potential rewards are equally profound. If we succeed, humanity might someday transcend the limitations that once seemed inherent in our physical situation. The cosmic isolation imposed by an accelerating universe, the finite resources of our solar system, the temporal constraints of biological evolution. We might join a community of intelligences spanning multiple cosmic domains, sharing knowledge and wisdom accumulated over billions of years of diverse development. When I look at the data from these distant galaxies, I'm reminded of early humans seeing the first flickering campfires of other tribes on the horizon, says Dr. Elena Morales, the astronomer who first noticed the anomalous patterns in the JWST data. Those fires promised connection, knowledge, partnership, the foundations of human civilization. These quantum patterns we're detecting at the edge of our observable universe may be the campfires of a much vaster civilization, one that spans cosmic horizons and that we might someday join. The journey will be long, but we've taken the first step by recognizing that the fires are there. As we reach the end of our cosmic journey, we stand at a profound threshold of human understanding. We've explored the boundaries of our observable universe and contemplated what might lie beyond. We've examined the possibility that advanced civilizations might exist beyond our cosmic horizon, forever invisible to us through conventional means. And we've considered the tantalizing evidence that these civilizations might have found ways to communicate across these seemingly absolute boundaries through quantum connections that transcend our classical understanding of space and time. Chad, quest to understand our place in the cosmos has always been as much philosophical as scientific. Each generation stands on the shoulders of those who came before, peering a little further into the abyss, catching glimpses of greater truths. From ancient stargazers who mapped the heavens with primitive tools, to modern cosmologists who probe the universe's earliest moments with space telescopes and quantum sensors, we've been driven by the same fundamental questions. Are we alone? What is our purpose? How does our story fit into the grand cosmic narrative? The possibility of civilizations beyond our cosmic horizon offers a new perspective on these age-old questions. It suggests that the universe may be far richer in intelligence and connection than we previously imagined, even as it emphasizes how much remains beyond our direct observation. It reminds us that our cosmic view is limited not just by our technology, but by the fundamental structure of reality itself, by horizons that may be permeable to quantum information, but impenetrable to conventional signals. This understanding invites both humility and ambition. Humility in recognizing the vastness of what we don't know, and perhaps can never know directly. Ambition in pushing the boundaries of our understanding, developing technologies that might someday allow us to perceive and perhaps even participate in a larger cosmic conversation that spans these boundaries. As our observatories peer deeper into space and our quantum sensors detect ever subtler patterns, we inch closer to a more complete understanding of our cosmic context. Each discovery, each theoretical breakthrough, each new detection of possible trans-horizon signals adds another piece to this grand puzzle. Yet we must acknowledge that the full picture may forever elude us, that there may be aspects of cosmic reality that lie permanently beyond human comprehension. This uncertainty is not a failure, but an invitation to embrace the mystery of existence while continuing to expand the boundaries of what we can know. It calls us to balance scientific rigor with philosophical openness, technological development with ethical reflection, cosmic ambition with human values. The coming decades and centuries promise remarkable advances in our understanding of the cosmos and our technological capabilities. Quantum observatories will detect patterns of unprecedented subtlety. AI systems will analyze vast data sets for evidence of intelligence beyond our cosmic horizon. New mathematical frameworks will help us conceptualize realities that transcend our intuitive understanding of space and time. But perhaps the most profound changes will be in how we see ourselves, in our cosmic self-conception as a species. If we are indeed detecting evidence of a vast network of intelligences spanning multiple cosmic domains, then we must reimagine our place in the universe's story. We are not the culmination of cosmic evolution, but perhaps its local beginnings. In our particular region of space-time, we are not the measure of all intelligence, but potentially just one expression of a phenomenon that manifests throughout the cosmos in forms we can barely imagine. This perspective invites us to look beyond our immediate concerns and consider our actions from a truly cosmic time frame. The decisions we make today about how we develop our technologies, how we structure our societies, how we treat our planet and each other, may determine whether humanity someday joins this larger conversation or remains isolated in our cosmic bubble, perhaps eventually falling silent like so many other potential civilizations. The stakes could not be higher. If what we're detecting is indeed evidence of a trans-horizon network of advanced civilizations, then we may be witnessing a future path for humanity, one that transcends the physical limitations of an expanding universe through quantum connections that span even the cosmic horizon. But reaching that future requires navigating our present challenges: environmental sustainability, peaceful cooperation, ethical technological development, and the preservation of human wisdom and values across generations. This is the choice that faces us: to remain fragmented and earthbound, potentially joining countless other civilizations that flared briefly before falling silent, or to unite in common purpose and develop the knowledge and technology needed to someday participate in a truly cosmic community. It's a choice each of us makes through our actions, our advocacy, our support for science and education, our commitment to a future worthy of humanity's potential. As you go about your life after watching this video, I invite you to carry this cosmic perspective with you. When you look up at the night sky, remember that what you're seeing is just a tiny fraction of what exists, that beyond the stars visible to your eyes, beyond the galaxies detectable by our most powerful telescopes, beyond even the cosmic horizon itself, there may be civilizations contemplating these same mysteries, perhaps even seeking connection across these boundaries. And consider this: if these civilizations exist and have found ways to communicate across cosmic horizons, what might they be saying to each other? What knowledge have they accumulated over billions of years of development? What challenges have they overcome? What wisdom might they share if we could join their conversation? Most profoundly, what might it mean for humanity if we are not alone in our cosmic bubble? If intelligence and consciousness are not merely local phenomena, but fundamental features of a mature universe, how would that change our understanding of our purpose, our potential, our place in the cosmic story? These questions have no simple answers, but in contemplating them, we participate in one of humanity's noblest traditions: the use of our consciousness to explore not just our physical surroundings, but the deepest questions of meaning and purpose. This exploration connects us not just to our ancestors who wondered at the same night sky, but potentially to other minds throughout the cosmos engaged in similar quests for understanding. Perhaps, in the end, this is what defines intelligent life. Wherever it emerges, this drive to understand, to connect, to transcend limitations, to find meaning in the vastness. Perhaps what we're detecting at the edge of our observable universe is evidence that this drive can succeed even against the most fundamental barriers of physics. That mind itself can find ways to span the seemingly unbridgeable gulfs of an expanding cosmos. If so, then our own quest for understanding is not isolated or unique, but part of a vast, cosmic process of awakening. A process in which countless civilizations throughout the multiverse may be participating, each in their own way, each from their own perspective, but all driven by the same fundamental impulse to know and to connect. As we conclude our journey together, I leave you with a question to contemplate. If civilizations beyond our cosmic horizon have found ways to maintain connection despite the universe's accelerating expansion, what might they know about consciousness, about reality, about purpose, that we have yet to discover? And if we someday develop the capability to perceive their messages more clearly, or even to participate in their trans-horizon network? How would that transform humanity's future? The answer may lie not just in our technological development, but in our philosophical and spiritual evolution, in our capacity to expand our moral circle to include not just all humans, not just all life on Earth, but potentially all forms of consciousness throughout the cosmos. It may depend on our ability to balance scientific advancement with wisdom, cosmic ambition with human values, technological power with ethical reflection. As you go forward from this moment, carry these questions with you. Share them with others. Support the scientific research that might someday help us answer them. And remember that in contemplating the possibility of civilizations beyond our cosmic horizon, you're participating in a tradition that stretches back to the earliest human stargazers and may extend forward to a future where humanity itself becomes part of a vaster cosmic conversation. Look up at the night sky tonight. Consider that what you're seeing is just the beginning, that beyond the limit of your vision, beyond the reach of our telescopes, beyond even our cosmic horizon, there may be minds contemplating these same stars, asking these same questions, perhaps even reaching out across boundaries we once thought absolute. In that moment of cosmic connection, you might feel both the vastness of what we don't know and the wonder of what we might someday discover. You might sense both our cosmic insignificance and our profound importance as bearers of consciousness in this particular region of space-time. And you might glimpse, if only for a moment, a future where humanity transcends its current limitations and joins a conversation spanning the boundaries of the observable universe itself. That future begins with the questions we ask today, with the research we conduct, with the values we cultivate, with the choices we make as individuals and as a species. It begins with our willingness to look beyond our immediate concerns and consider our place in a cosmos that may be far more connected, far more alive with intelligence than we have dared to imagine. So I ask you now, as we part ways, what role will you play in humanity's cosmic journey? How will you contribute to our understanding of these mysteries? What legacy will you leave for those who come after us, who might someday build on our discoveries to achieve what we can barely dream of today? The universe awaits your answer. The conversation continues. And perhaps, someday, humanity's voice will join the chorus that spans the cosmic horizon itself. If you've enjoyed this cosmic journey, please consider supporting our work by subscribing to this channel and sharing this video with others who might be fascinated by these possibilities. Leave your thoughts in the comments below. What do you think about the possibility of civilizations beyond our cosmic horizon? How does it change your perspective on humanity's future? Until next time, keep looking up. The universe has more wonders to reveal than we have yet imagined.